Hello everyone, welcome to my channel. Today's topic is SQL injection. So by the end of this video, you should be able to know what is SQL injection, why it's so dangerous, different categories, types of SQL injections, recommendations, detection, pretty much everything from blue team perspective. So let's start with the first slide. SQL injection, the beginning. So how everything started. The very first websites didn't have a database as they were too simple. They were static websites, which mean that they didn't require user input data. In contrast with the dynamic websites or the web applications, the difference between a static and dynamic websites or web application is that the dynamic websites can basically input data. Dynamic websites or web applications like Facebook, for example, where we can add comments, delete blogs, rename articles, or upload photos or anything like that. So most websites, other than the very simple ones, use database to store data. They store data such as usernames, passwords, news articles, blog posts, pictures, and basically anything that happens on the website. The web application reads the database and then displays the data to us or to the users. When the user performs an action on the website, the web application will either update, delete, or modify the data that exists in the database. This interaction between the web application and the database usually happens using a language called SQL. Okay, so just to give an example, here, let's imagine that this user is browsing a web application or the dynamic website, a bank website, and the user wants to delete a saving pod, and they're sending basically the request that they want to delete it. The website interpreted their request under the form of a language that the database can understand. So it will be something like delete from table where blah blah blah, or update table name, set column 1 equal to this or equal to that. You will see some examples when I'll start explaining the different categories and types of SQL injection, so don't you worry. This is just a basic explanation to see how actually this works. Okay, let's move on to the next slide. Application tiers. So a database-driven web application, or as I said, dynamic website. So let's understand that web application and dynamic websites are the same things because we can basically input data. So basically the dynamic websites and web applications work commonly use 4 tiers. The first one is the presentation tier. So here, the presentation tier are the tier of the web browsers or the rendering engines, such as Internet Explorer, Safari, Firefox. So this is the presentation tier where the user is seeing they're sending a request to the particular website, either GET request, POST request, or whatever. They are sending the request. The request goes to the logic tier. The logic tier is related to basically all programming languages, such as C#, ASP, .NET, PHP, JSP, and etc. This is the middleware tier. So its responsibility is to load, compile, and execute, like for example, index.asp. Once the information is being passed to the logic tier, it goes to the application tier, a server that hosts an application programming interface or API. So it interacts with the data store and imposes application and business logic. So here we will see services like CSC, AAJB, SOAP, RMI web service, and etc. And the last tier basically is the storage tier or the database tier. Databases such as Microsoft SQL Server, MySQL, Oracle, or anything. So its responsibility is to execute SQL queries or return data. Okay, so to sum up, the web browser or the presentation tier sends requests to the middle tier or the logic tier, which in turn calls the exposed APIs of the application server residing within the application tier, which services them by making queries and updates against the database or the storage tier. So that's how basically the applications or the dynamic website work using these 4 application tiers. Okay, so what is SQL injection and why it's so dangerous? How does it happen? Okay, the first question, what is SQL? SQL stands for Structure Query Language. We have to know that this is not a programming language. It is a query language. It's a domain-specific language for storing, manipulating, and retrieving data in the databases. So this is the only responsibility of the SQL language, meaning we are only querying data. We're not coding anything with SQL injection. Let's be clear. Okay, what is SQL injection? It is a web security vulnerabilities. So it's a vulnerability. It allows an attacker to use malicious SQL code, so crafted code for backend database manipulation to access information that was not intended to be displayed. So it's an SQL injection is an attack in which the SQL code is inserted or appended into an application user input parameters that are later passed to the backend SQL server for parsing and execution. So why SQL injections are so important and so dangerous? First, we can find them absolutely everywhere. Nowadays, most of the websites are dynamic websites or web application. So basically, we can find them everywhere. Secondly, they are very hard to protect against, and it's very easy to make a mistake and make these exploits available for misuse. And the other reason is they give the hacker access to the database. And why this is so important? In many scenarios, if an attacker finds an SQL injection, they don't need to upload a PHP shell or get a reverse connection. And of course, to try gaining access to the database and see whether they can read it. There's really no need to upload anything and increase the danger of being caught, because if hackers have access to the database, they pretty much have everything they need. They have usernames and passwords, and they can log in with a normal username and password as a normal user. Also, in some cases, SQL injections can be used as file inclusion vulnerabilities and file upload vulnerabilities, a reason why they are very dangerous and useful for attackers. Alright, how SQL injection happens? The first thing is an attacker must first find vulnerable user inputs within the web page or web application. If there is no vulnerable input where the attacker can actually insert their malicious payload, there is no SQL injection. And secondly, the attacker should create input content. It's often called a malicious payload, so malicious query, crafted query by the attacker. And last but not least, why SQL injection happens? Lack of validation and encoding of the SQL queries before being passed to the SQL database server for execution. I know this sounds a little bit difficult to understand, but I'll give you some examples when we are talking about recommendations for how to basically prevent SQL injection. So we'll be explaining this lack of validation and lack of encoding and other things that can basically prevent us from SQL injection. And let's move to the next slide. And we're moving to the next slide, which is SQL injection classification. So here we will classify the SQL injection. Basically, there are three main categories. The first one is the inbound SQL injection classification. I'll explain you absolutely everything for this category: inferential or blind, and out of band. So three main categories. The inbound SQL injection has the error-based SQL injection type and the union-based SQL injection type. The inferential one has the Boolen SQL injection type and the time-based SQL injection type. And out-of-band, DNS HB-based exfiltration is not kind of type, it's just a way of using the out-of-band categories in comparison with like the first two, where we can actually see the different types. All right, let's go and start explaining every single category one by one. So the first one is the inbound category. What you have to know for the inbound, probably self-explanatory. Inbound, so an attacker uses the same communication channel to both launch the attack, so start the attack, and gather results. The retrieved data is presented directly in the application web page. That's why it's inbound. So if we pretend we are the attackers, we can start the attack from the website, so sending our queries from the websites, and after that receiving the results from the same website. So same channel being used to launch the attack and gather the results. And here we have two different types. We have the error-based SQL injection. Again, probably self-explanatory, error-based. Here we expect some errors to be retrieved. The attacker injects crafted SQL queries that cause an error. So that's the main aim to the attacker. And after that, we have the union-based SQL injection. Retrieve data from tables within the database using the union operator. So from here, we know that the union basically is an SQL operator, and it's being used to retrieve data from the tables. That's why it's called union-based. Okay, and now in more depth. Let's start with the error-based SQL injection. As we said, is inbound SQL type of SQL injection. As we use the same channel for starting the attack and receiving the results. So error-based SQL injection. This technique relies on error messages thrown by the database server to obtain information about the structure of the database. So the attacker performs actions that cause the database to produce error messages. The attacker can potentially use the data provided by these error messages to gather information about the structure of the database. So that's the main aim of the attacker. What errors we would expect to see? So the attacker is hoping for verbose error pages, so verbose error that basically can throw more information, detailed information about the type of error. So can include sensitive information about database environment, users, schema information, or associated data. Here we have the different types of verbal errors, like the first one is syntax error, can be used to identify injectable parameter. This is one of probably the most useful error thrown by databases that attackers can use. We also have stack trace. Generates when the application crashes because of an error or an exception. So in comparison with the syntax error can give information about users' tables or anything like that, or version of the database, while the stack trace will basically show on which line is the particular error. We have logical errors, often reveals the names of tables, columns that cause the error. Type errors can be used to deduce the data types of certain columns or to extract data. So here we have, let's crafting SQL queries and how, so basically I want to give you some examples what the hackers are using to basically produce these errors. So the attacker used SQL injection commands in input field parameters, such as single quotes, double quotes, or SQL injection SQL operators like and or not. You see some examples in the next slide. But here, just to mention and to show you where the attacker can try to inject these parameters. So they can use, for example, the authentication login window page. So they can basically inject something in the email address or passwords, or they can use the URL, so modifying the hyperlink like 1=1 and single quotes or anything like that. You will see some examples, as I said, in the next slide. Searches boxes, so anything that we can input data, the attacker can use it to basically insert their malicious queries. So here, search boxes, retrieving relevant information from the database with these search boxes. And now the example of the error-based SQL injection and how they look like. Alright, here, let's pretend what's the action of the hacker. The attacker injects a single quote to cause an error. So here, he used the URL to inject the malicious query, and you can see from the example, he only or she add the single quote at the end of the URL. So here we can see cybertooltesting.com, shopproducts.spx category. Very important thing to mention, the category is the parameter. So everything after the question mark is basically the parameter. In this case, the category is the parameter, and the parameter is equal to artifacts. So if this website is like vulnerable, we know that the vulnerable parameter within this website is the category. So this is where the developers basically need to go and check this parameter. This is the vulnerable parameter. So the attacker injected this single quote and the server responded, "You have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use. And close quotation mark before the character string artifacts." Okay, what happened here? The system threw an error because of the single quote left unpaired at the end of the query. And as we said, the SQL injection, error-based SQL injection, the aim is to throw information about the database, something that can help the attacker to query their, to craft their next queries, basically malicious payloads, and they help them to hack the database. Here now, the attacker knows that the vulnerable parameter is the categories. The reason for the error is the single quote here. And we know something else. The server. We know that the database that it uses is not Oracle. It's not any other database, but it's MySQL type of database. Okay. So this is a normal SQL query. As I said, the hacker added the single query within the URL, and the web application sent the query to the database in the form of a language that the database can understand. So that's what happened in the backend. The web application sent this query to the website. Select from category where name is artifacts. Okay, this is the normal SQL query that should be. But what happened when the hacker added a single quote? He broke or she broke the SQL query structure. So select from category where name artifacts, and we have another single quote. So that's why we're saying here that the problem is a single quote left unpaired. So the database server would have expect to have another single quote here, as that's how the database works. Okay. Another example, it's not related to the previous example. This example, the attacker is trying to convert a string into an integer. So integer into a string into a number. Again, the hacker uses the URL. So cybertombtesting.com page.asp question mark. As we said, after the question mark, we call this parameter. So in this case, this is the vulnerable parameter is the ID. ID equal 1. Okay, we have an ID, we have a product from this cybertomb code 1. And the hacker added to the URL or 1 equal convert integer user dash dash basically every SQL query. So if we add this dash dash, it means that the SQL database will ignore anything after this dash dash. And the server responded with syntax error converting the varchar value croft to a column of data type integer. So what happened? The database server responds with syntax error. It's again syntax error, and provides the attacker with information about who the user is, as we can see here. So now we know who the user is here, and we can keep crafting our payloads, and this time using this user craft, as we know it exists within this particular database. And this is because the hacker tried to convert a string into an integer, and that's why the database is like, what the hell is happening? And it's throwing an error. Okay. The next inbound type of SQL injection is the union-based. The union-based, as we said, it uses the union operator. So the union operator retrieves data from tables within the database. This operator is used to combine the results of two or more select statements into a single result, and you will see how this works. Let's say that a database has two tables. The first one is called girls table, and the other one is boys. Okay, now we will try to use union operator to retrieve data, basically combine the data from these two tables. But before that, I want to tell you that there are some conditions that have to be met in order to use the union operator. So the first condition is every select statement within the union must have the same number of columns. Okay, here we have the same number of columns, 3, 3. Okay, that's good. We've met the first condition. The first one, the columns in every select statement must also be in the same order. Okay, girl ID, boy ID, girl name, boy name, country, country. That's nice. We're covering this as well. And the third one, the columns must also have similar data types. Yes, they have the same data types. The difference is that one is the table for girls, other for boy, but it's similar data types. All right, and let's now craft our SQL Union query. Select country. Okay, select from column country from girls, from table girls, union, so combine the results with the select country from boys table and order by country. So we'll order all the extract information by countries. And ta-da! You can here see the results that we combined the countries from both basically columns, countries from the both tables. And now I want to show you the SQL Union O. So there are union operator and there are union O operator. The only difference here is that we will get Spain twice, not just one. So here the union O, basically it will show all the data, no matter if it's duplicated. And here it will be without duplication. So now, when you know how this works, what is union-based SQL injection? The union-based SQL injection the union SQL operator combines the results of two or more select statements into a single result. If the application is vulnerable to union-based SQL injection, the results will be returned as part of the HTTP response. And by saying this HTTP response, because it's inbound SQL injection, and as we say, the inbound category, we will get the results from our query within the same channel. So we're using the queries, we're sending the query for from the particular websites, and we're receiving the results again on the page. And let's now see the examples of the union-based SQL injection. Okay, the first one, we have to explain a function that is very often used with union-based SQL injection, and the function is called concat. It's short from concatenation, which means to combine something. So it adds two or more strings together. This is the example. Select concat. Life is awesome. As I said, this function will combine the strings, and that's how it combines the strings. Life is awesome. All right, so that's the first image since we started. Okay, string concatenation. Bear in mind that depending on the database server, this function can be different. For example, for the Oracle database, this is what they use for the concatenate function. So it's pipe. So full pipe bar, it will be full bar. Microsoft SQL is the plus symbol for the concatenation function. the PostgreSQL use again the pipe similar to the Oracle. And here we have the space one for MySQL. Okay. So that's why it's so important to know what is the type of the SQL injection. And when in the previous examples we saw the error-based SQL injection where it's thrown the error showing MySQL when you knew that this was the MySQL, that server using MySQL database. And in this case, the attacker can start crafting and using functions that are specifically for the MySQL database. That's why it's so important to know the structure of the database server that we're trying to hack, or the hackers are trying to do. I will add in the description section of this video a very good SQL injection cheat sheet where you can basically read and see what functions are used in queries for the particular SQL databases. Okay. And now I will move to the examples of the union-based SQL injection. The first one. So here, union-based SQL injection syntax for extracting the user. Here the attacker is trying to extract the user. And imagine that this again is within the URL, and the attacker after the ID equal 1, as we said, this should be the parameter because it's after the question mark. And what the hacker is trying to do, union select null dash dash. So he's trying to enumerate and see how many columns are in a specific table, for example. So he types, or she types, sorry, union select null dash dash, and the database returns all queries in SQL statement containing a union operator must have an equal number of expression in their target list, as we said. If we want to use the union operator, there should be equal number of columns from the tables, and it looks like they're not equal, so it's not one here. The attacker is trying null null. Again, the server is responding with this, and then the attacker is trying null null null. We know that the server is responding with no error, meaning that there are 3 columns. So that's what they're trying to guess. Okay, then once we know that there are, for example, 2 columns, well, this is not, when we know that there are 3 columns, we will start extracting more information about like the structure of the table and like the database and etc. And we'll try to guess if these tables actually has a string or integer. So we will replace a null null for the first column, and if the data type of a column is not compatible with string data, the injected query will cause a database error such as conversion failed when converting the varchar value a to data type integer. So if here it shows any of this, it means that the column actually is an integer and not a string. And that's what the attacker is trying to achieve. And the last example here, I want to show you a successful data exfiltration, a successful SQL injection by using the union-based operator. As I said, is very often used with the concat function. So here, let's pretend that the attacker already know the name of the columns and the name of the tables. So they enumerated everything, and now they have started extracting data, and that's how it will look like. Union select username, this symbol, which they will use for concatenation. We can see pipe, password from so pipe was, I think, for PostgreSQL or Oracle, I think. They use a pipe password from users. So select username, select this column and select this column. So select the column username, select the column password from the table users, and concatenate the results from these columns, and that's it, the results basically. So the hacker knows that the structure of the two columns is the same because it's username and password, and we can see how the results are coming from the username and the password. They are concatenated, and between them we have the symbol. So this is the successful data exfiltration, and that's how it works. Okay, and now we will explain the different SQL injection types for the next category. This one we've just finished. We explained what is inbound category and the different types, error-based and union-based. So the second one is the inferential or blind category that consists of Boolean SQL injection and time-based SQL injection. All right, and let's start. All right, so what we have covered so far? So far, we've covered the inbound category with the error-based and union-based SQL injection types. If set inbound, we use the same channel to launch the attack and gather the results. Error-based, throwing an error. Union-based, it helps us to know more information about the data, how many columns, and also we can retrieve or exfiltrate data from the database server. And now we're moving to inferential or blind category, along with the Boolean and time-based SQL injection types. Inferential blind category. No data is transferred via the web application, and the attacker would not be able to see the results of an attack. Also, the hacker doesn't get error messages, and the attacker reconstructs the information by sending particular requests and observing the resulting behavior of the website or the database server. So here, what is important to know? That's why it's called blind. We're not getting any errors. We're not getting anything apart from some behavior, weird, abnormal behavior from the website. So anything that look out of the ordinary on the website page may indicate that our query has been executed successfully. So here we have two different types, Boolean SQL or content-based. It relies on sending an SQL query to the database, which forces the application to return a different result depending on whether the query returns true or false. I'll explain this within the next slide, but basically here it's Boolean true or false, again looking for any behavior from the website's database server. Time-based SQL injection. Self-explanatory. This technique forces, let me just move a little bit. This technique forces the database to wait for a while before responding after the query is submitted. That's why it's time-based. It depends on time. All right. Let's start with the inferential blind and Boolean content-based SQL injection. Boolean content-based. Before to explain what is the Boolean SQL injection type, let's explain what is Boolean expression. It is a logical statement that is either true or false. So yes or no. True, like 1 equal 1, 2 equal 1, etc. This is true. False, 1 equal 2, that's false, 2 equal 1, etc. The Boolean content-based SQL injection, the attacker sends a SQL query to the database, prompting the application to return a result. The result will vary depending on whether the query is true or false. Based on the result, the information within the HTTP response will modify or stay unchanged. So that's why we're looking for behavior. This allows an attacker to know if the result is true or false, even though no data from the database is returned. For example, let's first just show you how the attacker is trying to execute the queries. Here we have within the URL, the attacker is appending, basically adding n1 equal 1 or n1 equal 0, so either true or false, and this is how the database interpreted. Select from table name where ID equal 1, and this is the ID, the parameter, and here we can see ID equal 1 and 1 equal 1. So if ID equal 1 and 1 equal 1, that's true. And if ID equal 1 and 1 equal 1, that's false. And the attacker will see how the website will behave. So I'm just giving an example here. If you type, for example, if the website is supposed to show you your name, I have Lara and Wave. If it's depending on if your query has been executed successfully, it will either show the wave of hi, I'm Lara, or it will not show. So we're looking for anything thing that is out of the ordinary from the website. For example, imagine Facebook. You're trying to perform a blind SQL injection, Boolen SQL injection on Facebook, and pretend that here it says Facebook and page and blah blah blah, and you're adding n1 equal 1, and you press enter, and you see that in Facebook, within the login page of the Facebook, it will not show, for example, the logo of Facebook, or it will not show something else, or something will be reversed. It won't look like the normal Facebook page that you would expect to see. This means that it's vulnerable, the website, to Boolean or blind SQL injection. So that's why for the SQL injection, we are not seeing any errors, but we are paying attention to the behavior of the website, the database server. Okay. Now time-based or time delay SQL injection. So this type of blind SQL injection relies on database pausing for a specified amount of time, then returning the result indicating successful SQL query execution. For example, or actually before to proceed with the examples, here again, similarly to the concatenate function, depending on the database provider, they have different function to use for time delay. You can see MySQL is select sleep 10 seconds. PostgreSQL is select pg_sleep. Microsoft to wait for delay. That's why, again, as I said, it's very important to know what server has been running on the database. So what database server has been using for the particular website. And here we have an example. Microsoft SQL Server, Microsoft SQL servers have a built-in command to introduce delay to queries. So wait for delay. As you can see here, that's the function, wait for delay. When the first is hours, minutes, seconds. So if you want 10 seconds, we have to type like that. So for example, the following request to the cybertombtraining.com website take around 10 seconds. And how we build our query? We build it cybertubetraining.com if len user equal 1, wait for delay. So if the user has one letter, one character, late for 10 seconds, wait. But the page returns immediately. So that's the behavior. It returns immediately. After that, wait for delay 10 seconds if the user has 2 characters. Valid page returns immediately. Then 3 characters. Valid page returns after 10 seconds. So we're waiting for 10 seconds and bam, the page will show to us. Therefore, the database username is 3 characters. That's the result. So this is very time consuming. The blind SQL injections are very time consuming. So most of the time they're basically we use, so like the hacker use automated tools to perform blind SQL injections. Should agree it's quite time consuming to type every time 1, 2, 3 letters or whatever if you try to basically enumerate something and see if it's vulnerable to blind SQL injection. So that's why it's automated. Okay. And now we've just finished with the inferential blind category with the Boolean SQL injection and time-based SQL injection. And we finally cover these two. And the next one that we have to cover is out-of-band SQL injection. Our DNS HTTP-based exfiltration. You see how this works. Okay, and let's start with the last category of the SQL injection. This is the out-of-band SQL injection. So an attacker is enabled to use the same channel to launch the attack and gather results, in contrast with the inbound category, where the communication happens from the same channel. So we launch the attack and gather results from the same channel. This technique relies on the database server's ability to make DNS or HTTP requests to deliver data to an attacker, meaning if the database server doesn't have this ability to make DNS or HTTP requests, the out-of-band SQL injection can't happen. So now we'll be discussing DNS and HTTP-based exfiltration within the next few slides. So first, successful indicators. What do we need in order for out-of-band SQL injection to be successful? We need a few indicators, but before explaining them, I would like to explain you how the out-of-band SQL injection basically works. We have an attacker down here. The attacker injects malicious SQL command to the web server. The web servers then send the command to the database server, and if the database server is vulnerable, it will interpret the injected command, and then send an outbound request to a listening server. So here, just have a look that it's out-of-band request. So the results from the command are not going back to the web server and then to the attacker. They're going out. That's why it's out-of-band. They're going out to a listening server that belongs to the attacker. And then the attacker will go and collect the captured information from the listening server that belongs to the attacker. But in order this to happen, we need actually first 3 indicators to be met. The first one is the database system accepts and processes malicious SQL query. So lack of proper sanitization of web application level. So here, the web server should be first. The web application should be first vulnerable. Then, database system, this one here, should be able to communicate, or it's allowed to communicate on public network using either DNS or HTTP protocol. So if this is not met, we can't actually perform the SQL injection. I mean, it will be unsuccessful. And last, listening server is required to capture the information exfiltrated from the database system. So here, the attacker should have a listening server. Okay, now DNS and HTTP exfiltration. Protocol used for data exfiltration is DNS and HTTP. DNS stands for Domain Name System. It's usually on port 53, and its main purpose is to convert URLs and domain names into IP addresses that computer can understand and use. So this is an example. This is the computer where is www.cybertomb.com located. That's the DNS server, and to basically respond with an IP corresponding to the cybertomb.com website. Then the DNS-based exfiltration is the attacker must have access to a DNS server that is registered as an authoritative for some zone, like attacker.com in our example, where he can monitor each lookup performed against the server. I'll show you what we'll be using in order to actually have this DNS server. Okay, HTTP protocol, a hypertext transfer protocol. It is a method for encoding and transporting information between a client such as a web browser and a web server. The default ports are 80, 8080, 8000, 8081, and etc. HTTP data exfiltration. The database machine should have network layer permission to access web resources controlled by the attacker, and the database should provide functionality for querying external web servers. We will see this and more examples within the next few slides. Okay, Burp Collaborator. Probably you've heard of the Burp Collaborator. It's a platform, Burp Suite. It's a platform and graphical tool that work together to do security testing on online applications. It supports the whole testing process from the initial mapping and analysis of an application's attack surface through the discovery and exploitation of security flows. You can manually use Burp Collaborator to induce your target application to interact with the external collaborator server, and that's what we'll be doing. We'll be using Burp Collab to set up our own server. Okay, from listening server, from where you can listening and basically wait the vulnerable database server to send us the output of our command that we send to the web application. Okay, how this happened? So the Burp Collaborator used FQDN. So this is host unique FQDN, which stands for fully qualified domain names. It is the complete URL of a certain site or server on the internet. And you will see this and how it works. Okay, DNS exfiltration. So now I will be showing how the DNS exfiltration works. What do we need in order to create our payload first? Okay, so we need SQL function, SQL query or payload, and the domain. SQL function, I'll just give an example. SQL function, this is the same function. We just use the same function, but for different database providers. And as previously explaining about, for example, the concatenate function or the time-based SQL injection with the time delay function, and how it's different but depending on the database providers, here is the same. Have one function that is different for depending on the database provider. So we have the, for example, master XP directory. Okay, this function basically works to display a list of directory. And here we have the SQL query. In our examples, we will use two different databases. The first one will be MSQL, and to use the payload select system user and select DB name, database name. And for the second example, we use a Maria database provider and select plus version, and select user and select password. So for the first one, we would like to know the system user and the database name, and for the second one, we would like to know the version of the MariaDB, the user and the password. Now, we have this domain. This is our domain. So we have set up a Burp Collab domain, and the Burp Collab domain will give us this. This is our unique domain name that we'll be using as a listening server to retrieve, actually to wait for the database server to send us the result from our command. Okay, we continue with the DNS exfiltration example. Now, we use this function. I think this function was it was for MSQL. So we use this function, master XP directory, to display the directory. And we use the SQL command to select system user, select DB name. This is the FQDN, our unique domain name that we'll be using for the listening. And that's the payload, the query that we'll build, declare, varchar, declare, and here select, okay, from A, select system user, select at B, select DB name, that's our command. After that, execute this function, concatenate A and B variables. You can see variable A, variable B, concatenate the results from variable A and variable B, attach it, so combine it with our listening server, and that's it. And the result will be a DNS lookup that will be received for this domain. And look at that, we'll be able to see the exfiltrated data. So we have the SA. You can see here that it's dot. This one it's dot here. Dot. So the first dot is SA, meaning that this is the system user. And the second one after the dot is master, meaning that this is the name of the database. And after that, we have just our FQDN domain. Okay, and what we will actually see, this is how the results will be displayed to us using Burp Collaborator. So we'll have the DNS protocol, or this is a DNS exfiltration. This is like the payload. You can see it's our FQDN. And within the description, you can see the collaborator server received the DNS lookup of type A for the domain name. And we can see this. These examples has been taken from a very good white paper called A Study of Out-of-Band Structured Query Language Injection, written by Lee Chun Hao. I will also add the article within the description. So if you would like, you can go and read the whole white paper, basically for this amazing guy who put this very useful info for us. Okay, and let's continue with another example. The database will be the Oracle. This is the same function as the master XP, just it will be listening to the directory. It's just the function is different based on the different database, which is Oracle. In this case, we'll be using the command select version from the variable instance, select user from Duo, select name from the database. We have here our domain server, which is like a different one. And now we're building the payload. Select, here we have the this function, select version from, select user from, select name from database, and again concatenate everything and separate it with dots based on this and concatenate it to our unique work collaborator domain. And then we will receive, as you can see here, the version, the user, and select name from database here. And that are the results under DNS lookup. And you should be able to see how they look like when we capture it using our work collaborator tool. And this is 1, 2, and 3. And that's what we ask for within the SQL command. Okay, oops, that. All right, I will continue now to the next slide. DNS HTTP based exfiltration. So here I'll show you now by showing you the example and how it works. Just very quickly. Again, we'll see the same graph. Attacker injects a malicious SQL command. This is the command, as we said, the variable A, variable B, variable A looking for system user, variable B looking for the name of the database, execute this function, concatenate it, and add it to our unique work collaborator domain. And okay, the web server is vulnerable, and we'll pass basically the query to the database, and the database will process the query and will perform an outbound request to the work collaborator domain. And then the attacker will go and collect basically the captured information, which is the results from the requested command here. Okay, oops, sorry. Now HTTP based exfiltration. Sorry. Okay, and HTTP based exfiltration, it's pretty much the same as the DNS, but you see what's the difference. Now I have a function here, UTL HTTP.request. This function allows PL/SQL programs to create request context. So here we'll be using for the Oracle database, so we'll be performing this SQL command: select version from, select user from Duo, select spare from sysuser where row number equal 1. And you have the FQDN, which will be this one, our unique work collaborator server, and we have the following payload: select UTL HTTP request. This is the function, as I said, we use it to create a request context. This is our work collaborator, and here concatenate version, select from blah blah blah, user, which we use select user from blah 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 from Dual, and after that we want the hash pass from the spare from sysuser where row number equal 1. The results: HTTP GET a request initiated from the target Oracle database system containing version, user, and hash pass. So, how it looks like? We can see here DNS HTTP. This was the DNS payload, but you can see here the HTTP payload, and you can see get version, and you can see the version 10.0.0.0.0 user sys, and the pass, the hash pass, this one. So that's how it works for the HTTP. Now we have an advanced out-of-band SQL injection. Let's see, for DNS data exfiltration, what does it mean advanced? So we have a domain name specification. The domain name specification, it's a maximum 63 characters for each subdomain, and in total 253 characters for a full domain. Domain name is only allow letters, numbers, and hyphen. Example, this one. So here, max 63 characters for each subdomain. So this here subdomain, it can't accelerate more than 63 characters. And in total, the full domain, so all of this, it can't accelerate more than 553 characters. Otherwise, they'll be truncated. It's just, it can't happen. That's the rule. These are the domain name specification. So here using the DNS, this probably it might be a problem for us if you want to extract more data, because we should pay attention to the total number of characters. In this case, what will be the solution? We have two solutions here. The first one is the fragmentation method, and the second one is the encoded method. The fragmentation method splits the SQL command into two. So as I said, if it's too big and it's more than 252 characters, we have somehow to split the command. And the encoded method, here, for example, we use different function. For MSQL, we use the substring function, which extracts some characters from a string. So that's what we use for the fragmentation method. And the encoding method, the data is being encoded most often with base 64. So first fragment of malicious SQL query, just giving an example. This is the command, and here we have here the substring. We have the cast function. The cast function is used to convert a string to a numeric data type. After that, we have the server property function. It's used to return the information about different properties of system, or so-called the instance information. Okay, and we have then addition, as we have more information here. Max, blah blah blah. We here have binary base 64, so we know that the encoded method in this case will be using the binary base 64. And now select, replace, execute. We'll be executing this and concatenating the Qt variable, this one variable, select replace, to our current collaborator unique domain. Now we have the second fragment of the malicious SQL query. Just 1 second. Oh, that is, I'll explain this later. So this is the second one. You can see this is a different variable D, this one, that will actually, this is the variable D will be replaced, and this is like the main variable select, which will be here. And for the second one, we have, again, we declare the variable T, but we select a different variable E in contrast with the D. Substring is absolutely the same command. We're just splitting the command because it's too large, right? And here select replace variable E. Here execute, we execute absolutely the same, and we attach the result to the domain work collaborator domain that we currently have. And this is the output, what we will see. The Creo server receive a DNS lookup of type A for the domain name. This is the encoded base64. As we know, we are using base64, binary base64. So we are splitting the command into two, and we are encoding it with base64. So this is the result, is base64, and we attach the results of this here to the work collaborator domain. This is the second one. This is for the second fragment, and again, base64. Part 1, part 2 of the encoded data. And now we compile this base64 to the dot, and this base64, we compiling it, and after that, if you use, for example, CyberChef or a different tool, we decode the base64, and we can see the results, which is the express addition 64-bit, and that's what we were asking. We want to see the addition, which is a 64-bit here. And that's the response, but that's how it works. That's the advanced SQL injection, the DNS exfiltration. One of the DNS has this problem, as the data within DNS, it's basically appended here in contrast to the HTTP. So that's why the DNS exfiltration has a limitation, and we have to figure out how basically to resolve this problem, and that's how we're doing it, using fragmentation method to split the command, and after that encoding it, and once we receive it, we can just compile the base64, and after that decode it like that, and that's it. Okay, and we finally finished with the whole three categories of SQL injection. As we said, inbound, we're launching the attack, gathering the result from the same channel. Inferential, we're not gathering any error-based messages, any results. We are just paying attention to the behavior of the web application, either with false and true, either with false and true, so Boolean SQL injection types, and seeing how the web application will behave, if there will be some photos missing or fields missing on the web page, etc., or using time-based SQL injection, where we just put a certain amount of time, seconds or whatever, till the page show to us, and if the page waits for this specific amount of time, it means that our query has been executed successfully. And we have the out of band, where the basic channel, the channel of the starting of the attack is different than the channel of receiving, gathering the result of the command. Okay, and now the SQL injection detection, DNS exfiltration. We have. Okay, now next slide is SQL injection detection, and we'll briefly explain and give some examples how to detect SQL injection. So here we're looking for any indicators of SQL injection. So we'll pay attention to any operators like being like union all, concat, select, from, sleep, 1=1 for blind SQL injection, or anything like that. And this is just an example sample request. So you have the URL encoded format here and the decoded one. So cyber to meeting, month, equal, union select 111, and etc. And here you can see the encoded format, how the space actually is equal to %20 within URL format. So that's why you have to have signatures for a URL in URL encoded format as well, as that's how the basically it works when you put the URL encoded command. What I've been showing you is actually the decoded format, yes, union select and one, but I didn't show you like the encoded format, which is actually in the real life. That's what you will see, the encoded format. Okay, and now you start like working on creating signatures. You can, for example, I use Snort. This is one example, like IPvar HTTP ports 8080. This is just the variable that I use. IPvar is used for variable. So I want to catch traffic that is on 8080 ports, which are the HTTP ports. You can add more here. And this is the alert. I want to alert me on TCP when whatever is the IP address, whatever is the destination port, and whatever is the source IP address, but for the, sorry, this is a source IP, source port, destination IP, destination port. But when the destination port is 80 or 8080, I want to alert me on specific things. So when the content of the data packet is select or union, please alert me. And this is the message that I created. This is just the title of the signature that will via SQL injection detected based on select and union statements like this one. So that's how basically it works, and you can use like also different tools. So this was the Snort one. This is Zeek, which is like there's also like a traffic analyzer. Suricata, which is open source, and it's very good and like very handy tool. So you can use all of them for creating signatures, and basically they are network security monitoring tools for like creating rules. Okay, and SQL injection prevention. So recommendations for preventing SQL injection. The first one is the one actually we had it from some of the first slides. Using repair statements or parameterized queries is the same things. So this is where the SQL command uses a parameter instead of inserting the value directly into the command. This prevents the backend from running malicious queries that are harmful to the database. So if the user enter, for example, 1, 2, 3, 4, 5 or 1 equal 1 as the input, the parameterized query will search in the table for a match with the entire string 1, 2, 3, 4, 5 or 1 equal 1. So that's what the parameterized statement is. They separate the code from data, which is amazing, and probably is the best practice for SQL prevention. So here we have the prepare select from account where username equal speech mark. In our SQL, we insert the question mark where we want to substitute in an integer, string, double, or blob value. Okay, and like this function binds the parameters to the SQL query and tells the database what the parameters are. So here we have the insert into my guest, first name, last name, email. So we would expect only this, like for first name, here, here, and here, question marks. Okay, yeah, this is just an example how if we insert this here, it will be actually interpreted as like the whole thing instead of using like the interpreting like a query, SQL query, rather than just like a data input, which is great if of course we use the prepare statements. So now using the store procedures. So store procedures adds an extra security layer to your database besides using the prepare statements. It performs the escaping required so that the app treats the input as a data to be operated on rather than SQL code to be executed. So it's a prepared SQL code that you can save so that the code can be reused over and over again. You can see here the table customers, customer name, city, postal code, country, and store procedure. This is the syntax. So create procedure, procedure name, as SQL statement, and go. So this is select all customers, at city, and varchar 30 as select from customers where city equals city. So now we can't be just like surprised because we know we already what they should be here. And this is just an example. Execute the store procedure, execute select all customers, and city it will be Bristol. So both of them, like the prepare statements and the store procedure, both of them offer the same level of effectiveness. So it's up to you which one basically you want to use. Okay, the third one is validating user input. Even when you're using prepare statements, you should do an input validation first to make sure that the value is of the accepted type, length, format, and etc. Only the input which passed the validation can be processed to the database. It's like checking who is at the door of your house before open it and let them in, basically. Sorry. Okay, and the next recommendation is limiting privileges. Don't connect to your database using an account with root access unless required, because the attacker might have access to the entire system, and therefore it's best to use an account with limited privileges to limit the scope of damages in case of SQL injection. Okay, the next one is hiding information from the error message page. So error messages are useful for attackers as we already discussed. Sorry. As we already discussed in the previous slides, they are useful for attackers to learn more about your database architecture. So be sure that you show only the necessary information. It's better to show a generic error message that if something goes wrong, and encourage user to contact the technical support team in case the problem persists. The next one, some examples of error message. It's sorry, page not found, error 404, or oh, something went wrong, or this article not found. So you can use any error messages instead of showing them error, syntax error, this, or struct error, this and that. So that's why please hide your information from the error messages. The next one is updating your systems. So SQL injection vulnerability is a frequent programming error, and it's discovered regularly. So it's vital to apply patches and updates your system to the most up-to-date version as you can, especially for SQL Server. The next one is keeping database credentials separate and encrypted. So if you're considering where to store your database credentials, also consider how much damaging it can be if it falls into the wrong hands. So always store your database credentials in a separate file and encrypt it securely to make sure that the attackers can't benefit much. Also, don't store sensitive data if you don't need, and delete information when it's no longer in use. And last but not least, disabling shell and any other functionalities you don't need. Shell access could be very useful indeed for a hacker. That's why you should turn it off if possible, remove or disable all functionalities that you don't need to. And final thought, the key to avoiding being the victim of the next SQL injection attack is always be cautious and trust nobody. You don't know when the bad guy is coming, so hope for the best and prepare for the worst. Validate and sanitize all users' interactions. And alright guys, this brings me to the end of this video. Thank you so much for watching. I hope you really like it. If you like it, please subscribe. If you want to see more videos like this one, please share, like, and comment. I have more ideas for different content. It will probably more based on Blue Team, as I'm currently working as from like the Blue Team as an analyst. So let me know if you have any ideas for different topics, and if you have any questions, please leave a comment and I'll be more than happy to reply. Thank you so much, and bye bye. See you next time.